All right, welcome to this rapid fire explainer. If you're prepping for your PPL ground exam, you know the aerodynamics section is coming up. And understanding exactly how that plane gets off the runway, yeah, absolutely non-negotiable. So, ready to master the physics of lift? Let's just skip the fluff and dive right in. We're going to focus strictly on the 3 core principles of lift you absolutely need for your test. No rote memorization today. We're building a solid mental model so you deeply, intuitively get the mechanics of flight. Okay, first up, Section 1, Bernoulli and Pressure Differentials. Let's kick things off with how a wing's shape actually manipulates air pressure. Bernoulli's principle tells us there's a direct, inverse relationship between the speed of a fluid, or air in our case, and its internal pressure. Think about putting your thumb over the end of a running garden hose. You force that water through a smaller space, it speeds up, right? And the internal pressure inside that fast-moving stream actually drops. Well, air acts the exact same way. This right here is the foundational rule for why standard wings work. So how does this apply to your Cessna or Piper? Well, because a standard wing is cambered, meaning it's got that distinct curved shape on top, air traveling over the upper surface has a longer path. So it literally has to move faster than the air passing underneath it just to keep up. And because that top air speeds up, Bernoulli tells us a low pressure region forms right above the wing. Meanwhile, that slower air sneaking underneath, it maintains a relatively higher pressure. Boom, you've got yourself a critical pressure differential. And here's where it gets really fascinating. Nature absolutely hates an imbalance. That higher pressure underneath the wing desperately wants to equalize with the low pressure sitting on top. And in trying to do that, it literally pushes the wing upward into that low pressure zone. So it's not really that the wing is just being sucked up into the sky, it's actively being pushed from below. Pretty cool, right? Moving on to Section 2, Newton's action and reaction. If Bernoulli is all about the elegance of pressure, Isaac Newton brings the brute force. You probably remember Newton's third law from high school physics, right? For every action, there is an equal and opposite reaction. It sounds basic, but this is a massive component of total lift when you're up in the air. Here's how it plays out. As your wing punches forward through the sky, its physical shape, combined with your angle of attack, the angle it meets the oncoming wind, forcefully deflects air downward. This creates a massive downward directed flow of air, which in the aviation world, we call downwash. And this is literally Newton's law in action. The action is the wing shoving a huge mass of air down toward the ground. The reaction? Well, because the wing forces the air down, the air exerts an equal and opposite push back up on the wing. You are quite literally pushing air down to push your airplane up. All right, let's look at Section 3, the Coandă effect. So we know air gets pushed down to create that Newtonian lift we just talked about. But wait a second, what actually causes the air to turn downward in the first place? Why doesn't it just shoot straight off the back of the wing? Enter the Coandă effect. This is a crazy physics principle that dictates how a fluid, like air, tends to stick to a curved convex surface. Think about running the back of a spoon under a kitchen faucet. The water wraps around the curve instead of splashing straight off, right? Air does the exact same thing over a wing. Let's put this all together piece by piece. Step 1. Oncoming air hits and flows over the curved leading edge of your wing. Step 2, thanks to the Coandă effect, instead of separating, that air hugs the exact contour of the upper cambered surface. Step 3, this physical tendency forces the streamlines of air to bend downward as they hit the trailing edge. And Step 4, it's that exact downward turn that initiates the downwash required for our Newtonian lift. It's like a perfectly choreographed dance. Which brings us to Section 4, acing your ground exam. Let's wrap up this explainer with a rapid-fire review to really lock these 3 principles into your brain. When you get a question on the ground exam about how lift is generated, remember this trio works together. Bernoulli handles the pressure. Faster air on top equals lower pressure, giving you that upward push from below. Newton handles the action and reaction. The wing deflects air down, so the air pushes the wing up. And the Coandă effect? That's the physical glue making it all happen, making the air cling to the wing's curve to kick off that crucial downwash. So think about it. You aren't just looking at a hunk of aluminum or composite anymore. You're looking at a precision-engineered tool built to manipulate fluid dynamics, speed, and pressure. Knowing exactly how these invisible forces work together behind the scenes, how will you look at a wing differently on your next pre-flight walkaround? Best of luck on your ground exam. You are totally going to crush this. Oh, and if this explainer helped you visualize the physics of flight, please hit that like button and subscribe for more focused deviation study guides. Catch you next time.